I'm delighted to welcome you here for our Thought Leader series. This is an ongoing program here at Space Center Houston where we bring in leaders who are on the cutting edge of space exploration and what's going on in programming, not only here in the US, but around the world. And I'm absolutely delighted this evening to welcome Johann-Dietrich Woerner, who is the Director of the General of the European Space Agency. But before I move into some of my other remarks, I do want to recognize a few people who are joining us here this evening. I wanted to recognize Lon Miller, who's the Chair of the Board of Directors for Space Center Houston. We also have a number of officials here joining on with the ESA office. Would you all please stand for a moment just to be recognized? We're so delighted to have you here this evening with the European Space Agency. And we're also joined this evening by the German Consul General, the Honorable Woerner, and the Russian Vice Consul, Vyacheslav Levchik. If you please also stand and be acknowledged. Thank you so much for joining us here this evening. I wanted to share that Space Center Houston's undergoing a major transformation with the recent adoption of a new strategic plan framework, and we're now working on a new facilities master plan. While we continue to interpret the history of human space exploration, we're placing a much greater emphasis on current space exploration, new learnings and insights, and plans for the future. We believe that space exploration benefits humanity, and space and science learning is fun and engaging, and that STEM drives curiosity and achievement while fostering critical thinking and problem-solving skills that fuels innovation. So it's very appropriate this evening that we have with us Jan Woerner. I wanted to tell you a little bit about Jan before I turn the microphone over to him. He's really quite an extraordinary leader. Someone had been trying to get here for about 2 years. He was actually has quite a distinguished career. He was unanimously appointed as Director General of the European Space Agency by the Council in December 2014 for a term of 4 years. He was the Chief of the Executive Board of the German Aerospace Center and also served as Chairman of the ESA Council from 2012 to 14. And his career is quite distinguished, having studied civil engineering, and of course has been a real leader in policy and also in academia. And so he really brings quite a varied experience to his role as a director of European Space Agency. As many of you know, of course, NASA works very closely with ESA as well as JAXA and also Roscosmos. So we really are so delighted to have Jan here this evening to share some thoughts about what's happening with the European Space Agency. At the close of his remarks, I'm going to ask him a series of questions, and then we're actually going to open it up to all of you to ask questions. You can actually send your questions to thoughtleader@spacecenter.org by email, and we'll direct those to Jan at the close of the program. So with that, I'm now going to turn it over to Jan Woerner. Welcome to Houston.
Thank you very much. It's really a very special pleasure and honor, first time to be in Houston and already directly having the opportunity to talk a little bit about, as I say here, NASA, ESA, cooperation and more. And I call it Space 4.0, and this needs, of course, some explanation, so I start with that. If you are talking about Space 4.0, you should know what is Space 1.0, 2.0, 3.0. So Space 1.0, that was and is astronomy, very important thing. Space 2.0, I hope we left that across. This is the race in space in the 50s and 60s of last century, with a well-known competition between two superpowers, United States of America and Soviet Union, and all the people on the left and the right, you know all of this, and of course the results, who is the first on the moon, Neil Armstrong, Buzz Aldrin, as astronauts, and on the Soviet Union side it was the Lunokhod rover and also some moon sample return mission from the surface of the moon. So that was Space 2.0. We hopefully are not in that frame any longer. But at that time there was something more with animals, also some competition on the Soviet side. Laika, unfortunately, it did not survive the flight, and on the American side the monkey Ham. Europe tried to be part of that game, and this was what Europe did. A story nearly unknown, but it's a true story. The Europeans, in that very special case it was France, they tried to send a cat, a male cat, of course. The American astronauts, the Soviet cosmonauts. So Europe wanted to send a male cat into orbit. His name was Felix. But on the day of the launch, he disappeared. And so they sent a female cat in orbit. Like in normal life, they are more brave, and so that was a simple solution. At the same time, while this happened, in Europe there were some more discussions of how to work together. There were two institutions. One was the European Space Research Organization, and the other one, the European Launch and Development Organization. So they tried to work together beyond earthly borders. And in 1975, both of them were merged, and the European Space Agency was developed. European Space Agency, some people are asking me, what about Brexit and all of this? In order to understand that, one has to know that ESA is not part of the EU. We are an intergovernmental independent organization, and I will talk a little bit more about that in a minute. So, Space 3.0, this is where we are right now. We are at the end of 3.0, which is some steps for global cooperation and more space applications, and we call it the International Space Station. But if you look to the participating countries, the Americans, the Russians, the Japanese, the Europeans, and Canada, I see some more states worldwide, and therefore it's not really international, but it was a giant leap, to say that, to work together in space. Now, as I said, ESA today has 22 member states. 20 of these member states are at the same time also member states of the European Union. And that means 2 are not, and this is Norway and Switzerland. And in the future, UK will most probably leave the European Union, but they already decided to remain in ESA. So therefore, then this picture will be a little bit different, but the same. Slovenia is an associated state. Canada is a cooperating state, and on the lower part of this picture you see some more countries, and these are all the countries which are members of the EU, but not so far not member states of ESA, but we have with all of them agreements. So ESA is an intergovernmental organization, and it's working quite fine. So maybe I have to say one more word to that you see what is happening if you do something in Europe. You see here a list of flags. And these are all the member states, and they are in alphabetical order, according to the English alphabet. When I became Director General of ESA, I changed this order. It was before it was the French alphabet. And I changed it to the English alphabet, and you cannot imagine what that was. Huh? It was really a trouble. Is somebody here who can understand why I changed it? There was a reason behind. You all can understand? Very simple. Think about the French alphabet. What would be the order? Which country would be the very first one? Alemania. Huh? I thought with the German Director General, it's more humble to be in line, let's say, between France and Greece. This is okay. So therefore, I changed this order, and so far now it is accepted. So, as I said earlier, we have the European Union, we have ESA, and what is important that we are joining forces in Europe also to have common goals, and therefore a little bit more than 1 year ago, we signed a document where we described our goals for the future. And the first one is full integration of space into European economy and society, meaning, for instance, using Earth observation for daily use, weather forecast, or whatever. The second one, a globally competitive European space sector, meaning in industry as well as in academia. This is sometimes seen to be something just Europe. No, it's not just Europe, but you can only be a partner worldwide if you are competitive. If you are just somebody, you will never be accepted. So therefore, competitiveness is a very high value, as well as autonomy in some selected special areas strategic areas is important to show and justify that you have some capacity. Then because of that you are then also an accepted partner. So for instance, launchers, we have European launchers, we have a European satellite navigation system. Both actions are not independent of the world but in close cooperation. Now, what ESA is doing today is Earth observation, navigation, telecommunication, space science and exploration. We are developing launchers. We are doing technology development. We have, of course, satellite control centers. We are taking also care of space safety and security, be it now, for instance, on the Earth, on the surface of the Earth after tsunami or earthquakes, or in space debris, or also looking to near objects like here, Chelyabinsk, a meteorite hitting towards the Earth. And of course, also ESA needs administration, human resources, budgeting, and industrial procurement. So this is more or less what I wanted to say about ESA. Now I would like to show a little bit more about the contents. I said space 1.0, 2.0, 3.0, so now we are in a new world. Space is dramatically changing. I call it the shift of paradigm, where we see that the motivation why we are doing space is totally different than the ones 50 years ago. It's really a changed world. It's much more industrial driven than before. The actors are changing. We are not only having big space agencies doing space, but industry does now space by itself. Universities have their own space missions. The content is changing more and more. We have applications for each and everyone. You are using satellite navigation today, of course. And also these applications are now covering a lot of big field. And therefore, what is important, the roles of space agencies will change, and we are using new technologies, 3D printing, quantum entanglement, and all of this. And therefore, I call this new era Space 4.0. And on the right-hand side, you see a lot of things which are happening there. Commercialization of space, spin in, spin off. So the Teflon pen, as everybody knows, does not come from space. But for instance, the smoke detector is a typical example from human spaceflight. So this is spin-off. But now we are looking also more and more to spin in, to take technologies, for instance, from the automotive sector, to put them into the space sector. Then we have participation of the public. In the past, the space agencies decided directly, or the politicians, what to do. Today, we are also looking to the broad variety of citizens, what they would like to do. Diversity, information, innovation, interaction, inspiration, but again, very important for us, cooperation, and of course, jobs and growth and digitalization. And in this world, as I said, new technologies are really now coming into all what we are doing, whether it's nanotubes, bio-inspired material, 3D printing, or whatever you see. This is really something where we are now having a change in this Space 4.0 era. And as I said, the roles are changing. So the agency, ESA, is of course in the future still an agency, meaning we get the money from our member states. We then define a mission. We give money to industry to perform the mission, to build the mission, and then we finally get the results out of it. But at the same time, we have new roles, partners also of industry, or broker, meaning we are putting together different ideas to define a project even without an active participation of the agency. A mediator role, a facilitator and enabler. So the role of ESA is in the future, and I think this is true for all space agencies, is changing dramatically. Now some things about missions, and I have here just some of our scientific missions which we are now having, either we are doing it directly or which are in the phase of planning. So we will have this year a mission which goes to the Mercury, Bepi Colombo, which is a very special mission because Mercury is a little bit hot. And it's difficult to go there because of the gravitation of the sun, so it takes about 6 years to go there. We will have a mission concerning gravitational waves. I hope that we will have it earlier than 2034. And of course, this is not an ESA mission. James Webb Space Telescope, it's a NASA mission, but we have the pleasure to be able to launch this mission with Ariane 5. And for me, still, it's unbelievable that such a huge spacecraft can be folded in the fairing of a launcher, but this is the way it is done right now. And I'm really looking forward for this joint mission between NASA and ESA. And this is really a great achievement, and I hope that we will get very nice science by that. Maybe you have heard about Rosetta, a mission going to the comet Churyumov-Gerasimenko. This was also something very special in cooperation. There were also scientific instruments from many countries, also from the United States of America on board. And then we had a small lander, which was developed by some of our member states. And we brought the whole mission close to the comet. It took us 10 years, and after 10 years, this small lander could try to land. And this is something where you can learn something very much. I learned a lot, because you have to decide something. If you have a logic, then decision is simple. You follow just logic. But if you do not have, at the end of the day, a clear logic, then you have to have some gut feeling. And here the situation was that some 2 or 3 days before the landing, the experts told me, Mr. Woerner, unfortunately, we have to tell you that 2 things are not working on this tiny lander. The things are the following. The lander should, from 20 kilometers far away, should give just from a small impact from the main spacecraft, and then land softly without any control. It's far too far away. Without any control from Earth, it should land automatically on the surface of the comet. As the gravity of this comet is very, very low, what will happen? They explained to me, as a civil engineer, I had to learn it. So the spacecraft will go down, and then because of the elasticity of the arms, it will just jump away. And in order not to jump away, we have some harpoons on board, which we will shoot into the surface of the comet, and we have also a small engine which will keep us on the surface. And they told me 2 days before, unfortunately, these 2 instruments will not work. Neither the harpoons nor the engine. Because we have them also stored on Earth, and after 10 years, we tested them. They are not working. So what do? Do you land still or not? Of course, there was no choice. So I said, go ahead. And we had the situation that it landed. Everybody was clapping and applauding. But then it was very strange. The measurement was changing, and we knew, of course, in advance that there will be something happening, because it was flying again, landing again, flying again, landing again. Gravity is a rather safe thing. So after several touchdowns, it landed, and this is a first selfie. We did not know where it landed. This is a selfie on the surface of the comet. Now I will have this sound for you. The sound is just for the first touchdown, but because I love it so much, it is repeated. It's a replay, and I hope it will work. So that was number 1. It's the same touchdown. It's not many. Now you heard it. I will have also slow motion for you, of course. That's the slow motion. So out of this sound, the scientists defined about the consistency of the surface of that comet. So the sound was used to make scientific interpretation. Now what we can learn also from this surface, from this mission, is this is not white and this is black. All of this is gray, dark gray, as dark as charcoal. So we have some shades of gray, even more than 50 shades of gray at this comet. And therefore, what we had on board of this mission, cameras which can just make a difference between shades of gray, and much more than 50. And this camera, and this is a typical example of a purely scientific mission, was then transferred to a totally different application, in this case to early forest fire detection. So this camera is based on the technology of this mission and is overlooking forests, and if something comes out of the forest, some gray particles or whatever, the camera can decide whether it's vapor or whether it's smoke of a fire. So it's a typical example of a good example of technology transfer. Now we can learn more. You see here the comparison between America and Europe. The first one is a touchdown of Curiosity after 6 months.
Touchdown confirmed. Receive online.
That's America, right? Now the second part will be Europe. After 10 years of travel to a comet. 10 years, huh? So, different time. Control center, I don't talk about efficiency here. No. That's all. Okay? So, another thing I will explain you, what is different between US and Europe. This is a European mission going to Mars. It's called ExoMars. We want to look after life on Mars. And therefore we will go in 2020 with a rover to the surface on the Mars, and we will drill into the surface in the crust about 2 meters deep to see whether there is something like life, because at the surface the conditions are not good for life, but maybe over there. In order to do so, we need, for the data transfer to the Earth, we need a relay station. So we launched the relay station in 2016, having also some scientific measurements on board, in order to be ready for this mission. Okay? Now we said, okay, when we are going already now, why not having a test case with us to learn about how to land on Mars? It's difficult, and even NASA, having a big success, had also some failures on Mars. Mars is really difficult, as experts know. So what we did is, yes, the orbiter was in the orbit of Mars, excellent, everything fine. Then we kicked out this tiny demonstrator, and this demonstrator, before that happened, just to tell you here again, this is international, France, Italy, Germany, Russia, UK, Spain. So this is again showing that we are always working in an international frame. So what we did is, yes, you see here, you cannot read it, but I say it. So entering into the atmosphere, you need a heat shield. Then you can deploy a parachute, and you don't need any longer the heat shield. You separate the heat shield. Then you don't need the parachute. You separate the parachute. You start the engine, and you land. So far, so good. That was the plan. In reality, we came until here, and after 3 seconds, the computer stopped the engine and forgot about that there's still 3.7 kilometers ahead. So we had a landing, but not a soft touchdown. Now, what the important thing was, we got all the data here, we got it. We know exactly what was wrong. So we learned. Failure is just a data point. So we learned about it, and it was a test case. We just wanted to learn. Now we know what we did wrong, and therefore we can do better next time. But anyhow, the press did not accept that. Press said, Schiaparelli, that's the name of this lander, probe crashed, making it 2 failed landing attempts from ESA. So I had really a hard time. Now you know some other guy here in the States called Elon Musk, right? Elon Musk tries to get the stages back in order to have reusability. And he tries to land on drone ships or barges, or however you call it, on a drone ship. The picture, the movie I'm showing you now, is his third trial. The first 2 failed. This is the third trial. The satellite was in orbit, like our Tracecast orbiter. And he did an additional test with his to land softly on this drone ship. Unfortunately, it did not work 100%, but of course, he learned a lot of that. Now let's look into the press. German press. SpaceX failed again with landing trial. Launcher absolves crash landing. Yes, right. Okay, American newspaper. Falcon 9 almost landing. And Elon Musk himself made a tweet saying, ship is fine, minor repairs, exciting day. Now imagine I would have said after Schiaparelli, Mars is fine, no repair, exciting day. I would be fired. So therefore, it's about risk-taking. So, coming back to other stories. We do not have German astronauts, Italian astronauts. Hans Schlegel is here. He is not a German astronaut, but he is a European astronaut with a German passport. And all our different astronauts over here coming from UK, Denmark, Germany, Italy, France, and Italy, they all are European astronauts. We do not have these national astronauts any longer. We have always European astronauts with different nationalities. And this is one message. The other message is the following. These are the two flags of Ukraine and Russia. And in 2014, that was a starting point of the Crimea conflict. And that was exactly the date when one of the European astronauts should be launched. And I was at that time responsible as the head of the German agency, the space agency, and I went to Baikonur for the launch. And I was really afraid, will it happen or not, because of the Crimea conflict. And then I saw this picture showing an American astronaut, Reed Wiseman, a cosmonaut, Maxim Surayev, and a European astronaut with a German accent, Alexander Gerst. And this picture says something. It says that we in space, we can bridge earthly crisis, and we should always remain outside daily politics. We should really try with space to bridge earthly crisis, because at the end of the day, we need to work together. And so I'm very happy that the International Space Station is a place where we always work together and where we are doing also experiments of a very different type, whether it's medicine or whether it's Earth observation or whatever. And we are now trying to also to commercialized partly our research on board. So for instance, you can buy through ESA transportation to the station and back for what we call ice cubes, so not CubeSats, which is well known, but ice cubes. So companies can have in these cubes their microgravity research. We take the responsibility to bring it up to the station and back. And then this is, they can buy it for about 50,000 euros. And for universities, we have a better price, 35,000. But this is a typical example of commercialization, and also outside the International Space Station at the Columbus module. Christopher Columbus, this guy is very well known. His younger brother is Bartolomeo Columbus, and therefore, as this is called the Columbus module, Hans, you remember you were bringing it up to the station. There we have now here outside infrastructure built by industry and used by different companies for specific purposes. So where's the next destination? Some people are saying Mars, some people saying Moon, whatever. It's an open discussion, and I will say two things. Number one is Mars is not the ultimate goal. I hope humans will go even further. That's number one. Number two is, but Mars will not be the next destination, because of very simple reasons. To go to Mars and back, it takes about 2 years, meaning 6 months going, 6 months back, and unfortunately the two orbits are different, so you have to stay there for a while, and this means 2 years. And this is, of course, a very special challenge. People are saying, that's not a problem. Some people are staying in Antarctica for that period, or even in the International Space Station. But in both cases, in case of some emergency, you can come back. While here, if you go, either you have a technical issue or you have a medical issue, you have to stay. You just have to wait. Therefore, I think we have to have better systems to go to Mars and back for the future. We need also concerning health, as I said, radiation, but also if we land on Mars, we need, of course, a rocket over there, where to get the fuel from. So it's really, it's a challenge. Humans will do it, but not so quick. But to go to Moon and back takes a week. So you can do it during the summer vacation. And therefore, I think that's the right way to do. And there we are now also with the what is called now Lunar Orbital Platform Gateway, so the NASA proposal of how to go and to make not a new station, an International Space Station, but a station around the Moon where you can go and leave and go down to the surface. And of course, then you need a special spacecraft, and this will be the Orion spacecraft, having also a very special thing, the so-called service module. And this service module, which is the part which failed at Apollo 13, because of some explosion. This is now produced in Europe by ESA, and therefore it's a very, very intensive partnership on the critical path. So without the service module, the whole mission will not work. So therefore, we are very happy that we can be partner on the critical path, and this shows that NASA and ESA are very valuable partners. So the moon is a very important place, and I believe and I hope that we can use the moon even more than the International Space Station for international collaboration. Doing there a lot of things. You mentioned already STEM. I always add in STEM another word, another letter, that is A. So it goes to STEAM. For A, there are different explanations. I say just any other subject. So science, technology, engineering, any other subject, and math, which I will show you in a minute why I say that. But we can do there human and robotic exploration, public and private exploration, pioneering. So whoever wants to go there, we can do their moon science, a lot of things. It is at the end of the day also a stepping stone to go, for instance, to Mars. And therefore I think this is a good idea. We call it now Moon Village because of a totally different type of, it's not one mission, it's an open concept with free and open access for each and everyone. So the question is how to build it, and I can tell you we are building it right now. We have a Moon Village Declaration, a lot of worldwide entities signed it, and the way is how we will install it is very simple, and this is a broker function of ESA. So we are asking the different entities, whether it's private or public, what are you offering? Transportation, landing, science, mining, whatever. And then we have for all these entities information, and we ask them in addition, what are your requests? What do you need? And by putting these two matrices together, you get several missions. And this is right now what we are doing. And there is already something, for instance, here together with ESA and two British companies, we are building up a communication for the surface of the moon. So this is already a part of this Moon Village, and others will follow. For instance, to build on the far side of the moon a space telescope to look deep into the universe. And the Americans are also now providing. NASA said, okay, we are ready to build the roads. I was a little bit hesitant when I heard about that, even reluctant, because I thought then they will have the same speed limit as here in the United States. And this is not, for me, not the best solution. So Jeff Bezos was saying, vision for a city on the moon, of course, United States of America is always bigger than what we can think about. So we thought about a village. He is thinking about a city. I'm happy with that. Elon Musk is saying, fly me to the moon, okay? And he is providing ideas about a moon-based alpha, which comes back to an old movie. But this is what he announced in IAC last year. So he's also now providing some activities on the moon. And companies are already using the moon ideas for their commercials, saying, we have the houses for the Moon Village. Okay, so what are we doing finally with space? We are tackling global challenges. You have here a list. It depends on you, what you have the highest priority, but all of these are things we have to consider. For the first point, I would just to mention climate change. We can observe it, whether it's man-made or not. I don't enter into this discussion right now, but there are a lot of things which show that there is a climate change. We have a shortage of resources and so on, conflicts and catastrophes on Earth. And another point, curiosity is something which we should never forget. This is what is driving humankind. Curiosity is the strongest driver. And therefore, global challenges need global cooperation. So for me, it's not something we can do, but we must do. And with that, I would like to explain also, finally, what is the impact on our society with space. Sometimes people are saying, yes, space is nice, okay, for the space people, baptized with the water of space, and blah, blah, blah. We have some more issue. What we can see these space missions always, that people are fascinated by it. They are fascinated. Nobody cannot be fascinated if he or she sees a very special space mission. So fascination is a basis. The second thing is that maybe not all of these people, but many, get some acting in their brain, saying, okay, I'm fascinated. Now, what did I see? I saw that somebody had a dream, and this dream was realized. And we call that inspiration. So the second part after fascination is inspiration. And if you are inspired by something, you may be motivated to do so. So that means you make another transfer in your brain and saying, okay, it's not only the question whether I do a space mission, but if I have an idea for something, a dream, then maybe from my fascination and my inspiration, I come to the motivation to do something. And this is at the end of the time the best we can have for our society worldwide. We need motivated people for the sake of humankind. So this is ESA and NASA finally. And to be very clear, you will now see the euro and the dollar sign, and the size is proportional to the budget. So that's all. Thank you very much for your attention, and now I'm ready to discuss. Thank you.
Wow, yeah, that was fabulous. So much to talk about. It's really fascinating. Well, I think I'm going to ask a couple of questions, but I do want to open it up to the audience because I'm sure you all have lots of questions as well. But one topic that's really important to us is encouraging that next generation of explorers and scientists. And I know that science education is very important to you. That's critical to us as well. And I'm curious about your thoughts. I do use STEM because people recognize it, but I talk about science learning because I think it's the foundation of all learning in all areas. But what are some of your ideas of ways to engender that passion, that interest in young generations?
I'm really convinced that you will not raise passion by just teaching something or by just showing something. You have to give them the possibility to change the system, to really act in it. And that means all these study programs which are now existing worldwide at universities or wherever, also in the institutions at NASA and also at ESA, to give young people really the opportunity, number one, to participate in space activities, number two, which is even more difficult, to give them the chance to define space activities. Therefore, when I said participation as Space 4.0, this is something we should really risk. It's not a risk, really. We should really support that young people have nice ideas, and we should not say, we tested that already, it's stupid, we did it all the time differently. That's the wrong answer. There are always some smart ideas, and so that's at the end of the day the best we can do to motivate them to go into science. Again, this is, for me, it's one of the importance of space that we can really introduce this.
It's something that we've really embraced here, and you referenced to citizen science, how we allow the general public to actually participate. Something that NASA initiated and we were part of here at Space Center Houston was a Space Robotics Challenge, and it was a way to program Robonaut 5 or Valkyrie. It was a virtual challenge, and what I loved when it was held here was the person who won 3 of the 5 challenges was a stay-at-home dad. He actually figured it out and in sequence. What are some examples of citizen science projects that are underway through ESA?
Yeah, so we have different types. We have one in our ESTEC, in our technical center close to Amsterdam. We're also doing similar things. But what we also did, because we have, as I said, 22 member states, we invited citizens in all member states on one Saturday to really define with us the future of space activities. So we call that citizen debate. We had it at the same time, which is simple because we do not have any time delay between Estonia and Portugal. But we had online we connected them, and we had people between 15 and 18 years old discussing, not filling out a questionnaire, but discussing, moderated discussion about what should be done. And it was interesting, some people, for instance, the strong will to do exploration. For you in America, this is simple. It's trivial. For Europe, it's not at all trivial that we pay money for exploration, because there is always the question, what is the return of investment? That's the next question, the very next day. And so therefore, but citizens see it differently to politicians. They really strongly argued in favor of more exploration and science. And this is for us then a good argument also to go to our member states and say, you see, we have to do it, we like to do it. So hands-on experiments, yes, but also to get information and opinion what to do further on. Both at the same time.
Fantastic. I want to now open it up in the interest of time to the audience. If there are people who have questions, yes.
Or comments is also, if you
Yes.
want to complain or so, it's fine.
Somebody here.
It's unfortunately it's not English, it's broken English. So we have in ESA 3 official languages: broken English, French, and German. But in our that means in our formal meetings we have always simultaneous translation. But for instance, for me, as you really simply could recognize, I'm born in German and have not only a German passport, also a German accent. I talk in all our meetings English because, again, I think it's not very nice that the Director General, elected by all the member states, speaks then in his mother tongue. So therefore, I'm using English only, but it's translated and always in these 3 languages. And in the floors, it's depending. In Paris, you can hear a lot of French. In Italy, in Esren, you can hear Italian. But officially, that's most of the cases they are talking in English.
Great. And I know we have a number of people who are watching on Facebook Live, and we've had some questions emailed in. So, Elise, can you share a question?
So I don't know whether you could get the question. So the question was about the moon activity. What would be the role of ESA? And that's strange. The answer is strange. I don't want to be the master of that game. I was asked sometimes, do you want to be the mayor? No. That's a total misunderstanding of the whole story. There is an idea on the table. I don't ask who had that idea. It's not important. The thing is, the Moon Village, or however it's called, is a possibility on working together in the future in a different setup. Not with new fences, not with new regulations at large, but just to work together globally. And therefore, I think there is a chance that we can do it. Space can do that better than all other areas. And therefore, ESA has some, in this matrix consideration, which I explained to you, also ESA has some parts, and together with some other partners, we will make some missions. So for instance, this with the Lunar Orbital Platform Gateway, we are now developing the service module. This is part of the transportation, so we are part of the matrix. With Russia, we are developing a lander for the surface of the moon. We are part of this method. With these British companies, we are developing the telecommunication to the surface of the moon. And always it is not a single activity only, but it is within a common umbrella. And therefore, of course, we should be blunt. America is the strongest country in space, and of course the lead, for instance, for this Lunar Orbital Platform Gateway and all of these activities will be with the United States of America. But is that a bad thing? For me, it's not. Very simple. So we are not looking for the master role.
Yes.
I was wondering if there's any missions looking at going back to Venus anytime soon.
So the question was, are there any missions looking to go back to Venus?
So we have now in our science missions, I have to look to my program advisor. Where is she? You are there. We do not have a mission right now to Venus, right? No. Okay. Meaning no, I'm not right, or no, we don't have. We don't have, yes. So you see, our missions, our science missions, are in a very special way defined. They are defined 100% bottom up. So scientists are meeting. We have a special science budget defined by our member states. And then within this budget, they are creating the different missions, and I showed you a list of that, which is then, let's say, 20 years, for the next 20 years already defined what we will do. And in this line, Venus is not part of it. The other one, it could be in the exploration, which is a different program. There we have right now a focus on low Earth orbit, Moon, and Mars. But you're right, Venus is an interesting thing because many people do not know, but the exploration of Venus was the basis to understand the climate change, because Venus has a greenhouse effect much stronger than the Earth has. So therefore, it's important to go back to Venus, or as I said with the Moon, let's go forward to Venus and let's go forward to the Moon.
Great. Let's go back to an online question.
Yeah, so we have one from Esteban, and he wants to know, what, if anything, is your dream space mission?
You see, the problem is I'm a director general. I'm not a director special. If I now say a dream mission, then I get immediately phone calls from my directors and saying, why did you not say the Earth observation looking for CO2? Why did you not look for the quantum entanglement mission in telecommunication? Why the hell forgot you about the new navigation system we are developing? Why the hell not the new type of launcher, blah, blah, blah. So I cannot answer that question.
Okay, you're in the front.
I have a comment. I respect your observation of going to the moon as the next target. But before we went to the moon, John Kennedy said that we were going there not because it was easy, but because it was hard. And we've been there now. And we should go back, but it's for utility reasons. And there are those of us who think that the challenge and vision is that we should go to Mars because that's for exploration. And that's really what we live for, is to explore.
I could mainly confirm what you are saying, that it's exploration is something which is in our heart, in our soul, to discover. Curiosity is a very strong driver, as I said. But if we want to go to Mars, we better should prepare it. When Kennedy said, let's go to the moon, he did not, next time he did not launch a spacecraft to the moon, but we had first the Mercury program, Gemini, Apollo, and even with Apollo we had several, right?
We were not prepared. He announced we were going to the moon when we were flying Mercury.
Okay. So,
Surprised when he announced it.
yeah, so what I'm saying is, if somebody would announce today, let's go before this decade is out, it's too short, but let's say next decade as well, to Mars, that's still too short. We should not be naive. The conditions to go to Mars are so harsh, and we better have a stepping stone between. And so for the moon is for me as well a stepping stone. Also some other aspects. Moon science is something which was not done, so we can do a lot more on the surface of the moon than in the past. We went to some special places, but these special places do not tell us the whole story of the moon. And therefore I think the moon has scientific value, technological value, commercial value, and therefore also as a stepping stone. Therefore I'm a strong believer that we should really go forward to the moon and use it as a pit stop to go to Mars.
Go back to an online question.
Anastasia and Rob both asked, what is your opinion on collaborating with China on future missions?
So, this is a typical question, getting it in the US always. For us, of course, we make difference between different countries. Of course. We do not forget about human rights. We do not forget about intellectual property rights. Blah, blah, blah. We do not forget. Very important. But at the same time, to forget about cooperation just because of that would be a big mistake. Look back to 1975, and if you are in this building, you can see what happened in 1975. Soviet Union and United States of America made a joint project, Apollo plus Soyuz, rendezvous and docking. If you back in that time, it was really a Cold War, you could say, why the hell should we work together with Soviet Union? They are our enemies. You can say that always, but I think by bridging these earthly problems with space, without forgetting intellectual property rights, human rights, and all of this, it makes also sense to work, for instance, together with China. We have some projects, but purely scientific projects. We have some projects with China, but of course not at all in that amount as we do with NASA. So NASA, America is our prime partner. We have strong partnership also with Russia, as America has also with the International Space Station. So there are different levels of cooperation. And in each and every case, we have to decide whether we want to do it or whether we don't want to do it. But for me personally, space is an opportunity to work together, and isolation is not a good instrument.
Great. Yes.
No, that will not work. So if America really would say stop, then the other partners cannot do it alone. Without America, that's not possible. For me, it is important, we have to be clear, as our life is limited on this Earth, it is also the life of space station is limited. Very, very factual. The question is, when is it? And how do you go to the end of the lifetime? Huh? It's the same as with us. So now I heard that there is a discussion that in 2025 that there should be more privatization or private activities or commercial activities, however you call it, on the International Space Station. And as I showed you already, ESA is also doing that. Japan is doing that already right now, USA as well. Maybe Russia not in that amount. But therefore we have to see what that means. What is clear for me, and therefore I said our exploration strategy has three targets, three destinations: low Earth orbit, Moon, and Mars. Even if in 2025 or 2028 the International Space Station has to be deorbited or whatever, we need experiment, we need possibilities to go to low Earth orbit, because it's for microgravity research much too valuable. For medical research, for instance, immune system, blood pressure, salt regulation, all of these things, osteoporosis, I have to be careful because here are so many experts and I'm only a civil engineer, but all of these things can be investigated in low Earth orbit in microgravity conditions, so we cannot stop that. But we have to see, and we are in discussion with NASA, of course, what that means, what we heard. So far, Europe decided only to go to 2024. Now, therefore, and that's the same with all the other partners. Huh? There was some announcement from Russia, 2028 and so on, but formally speaking, it is until now, it is 2024 is the date. And we have to see how to go on. I mean, we have that lab. It is an excellent lab. You can do a lot of experiments. I would like to go there also. But the question is how that works. A total privatization of the American part is really difficult, because I don't want to talk too long about that, but all these space station activities are based on national governmental agreements. Not only NASA, but it's a governmental agreement of United States of America with the different other member states participating. Not only ESA, it is a member state. So it's a governmental agreement. And if now one government hands this over to a private company, if this would be the idea, it's very difficult. For instance, we don't pay for our astronauts in cash, but in barter elements, the Columbus module and others. So if this is a private company, does that work any longer? So it's complicated, but personally I believe that the station will be used also after 2024 and will be still very much used by public entities, maybe with more and more commercial activities.
Interesting. We're going to go back to an online question.
Ian would like to know, when will you meet the new NASA administrator?
I met him yesterday.
Do you want another one?
No, I was in Colorado Springs, and Jim Bridenstine was also there. And then the Vice President Pence said in his announcement on Thursday there will be the election of the new president, new administrator, and the candidate is Jim Bridenstine. I knew him from last year already. I met him last year also. Therefore, we'll see. I will see. Of course, the relation between NASA and ESA is of utmost importance for us, and therefore I hope that we continue. Also, we had an excellent time with Charlie Bolden, before also Mike Griffin, Charlie Bolden, now Robert Lightfoot, the last 1.5 years, and I hope that this continues also with Jim Bridenstine. So I'm sure I will meet him now in his new position very soon.
Great. We have time for one more question.
I have to apologize for long
Oh.
answers.
Oh, no.
No, I'm too long. I'm a professor. What do you expect?
Here. Yes.
What are your prospects for ESA's budget going forward? Do you guys have any way to maybe increase your revenue or your operating budget?
So, that would be a nice question for my program advisor. So what the Director General has to do is, he has, once a year, he has to present what is called a long-term plan. This is a 10 years plan of funding. And the member states ask me also, I should write down the affordability of the member states. And I always say, how can I define the affordability of a member state? They should do that. But anyhow, we are doing it. And so for the next 10 years, we have a proposal, and I presented it to the member states, which is based on these different columns I showed you. So first, the application column with Earth observation, navigation, telecommunication. The second one, the column of space science and exploration. The third column, which is the launcher, as I call it, enabling and supporting launcher technology and operations. The fourth color, space safety and security. And overall, we see more or less a constant, based on today's number, a constant budget of that. Plus, we are getting money from the European Union, paying for Copernicus and Galileo 2 space programs of the European Union. Now, this is just my proposal, my expectation. In fact, we have all 3 years, we have what is called a ministerial. This is a very special thing. If you have a chance to see it, it would be, you should do it. So it's a 2 days meeting of the ministers of all the member states of ESA. And I have officially, the Director General has to give proposals for all the different programs. So I have to say, okay, let's assume now an example, a manned mission, a human mission to the surface of Jupiter. A little bit stupid, but okay. And I say, okay, and I expect this costs 2 billion. So I write down proposal, blah, 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 2 billion euros. And then there is a document called document 100, where all the different proposals of the Director General are mentioned, also the price tag, and then the different countries. And then the different countries come and say, okay, maybe France comes and say, okay, Jupiter, sounds good. Let's have 50% of the price we pay. Then they write either 50% or they can calculate and say 1 billion. Other countries saying this and this and this. And then if we reach the 2 billion, I say, okay, we go for that. If we reach only the 1.5 billion, I say, no, with that we cannot do it. Either we can scale it down or we better erase it. And this is a 2-day procedure, and by that we're starting with 0 euros at the beginning, 0, and after 2 days I have to see whether we have enough money for the next years. Last time, just to give you an example, we started in the morning of the first day, I gave my proposal, they signed up with their numbers, we had 8 billion. I said, okay, I said before to my staff, if I reach 8 billion I will buy a new car. So I directly ordered the new car, and then I waited for the second day, and we were at 10.3 billion. So there is some dynamic in it. One mission had to be killed during these 2 days. As I mentioned, as I said this example, it was not the Jupiter. I had to kill one, but at the end we have the money. So I expect it depends really on the politicians, and my expectation is space is getting more and more important. Also, we get more and more private activities. We can do with the same amount of public money as in the past, even better things in the future. So I expect for ESA a constant budget for the next 10 years, more or less. Expectation. Next year, invite me again. At the end of the year, I can tell you better things.
Absolutely fascinating.
Where? The moon, SLS. You are building the SLS, you can see the model outside, so this is excellent, and we have all the different, so I don't know whether that is fits to your question, maybe it was misunderstood. Yes, so we need solid stable transportation systems, you're right, but we are in a better situation than in the past. We have private entities. Here in the US, you have a lot. You have Blue Origin developing New Glenn, New Armstrong, and all of this. You have Falcon Heavy. You have now the BFR under development. You have many activities. SLS as the NASA launcher, which is really an exciting thing. Therefore, it's getting more and more stable. And on German, not on German, European side, we are building two new launchers, a family of launcher called Ariane 6, two versions, Ariane 62, 64, which are substituting the Ariane 5, successful Ariane 5. And we are building a new launcher, Vega C, which is the successor of Vega. So we will have also a European, tiny European launcher family, but a very reliable one. And all of them will be used to transport cargo and humans, low Earth orbit, moon, and beyond.
Well, Jan, thank you so much. We could stay here for much longer, I'm sure, and ask you many more questions. And I think what that means is we want you to come back again. Happily next year so we can continue our conversation. It's been so fascinating having you here. It's so interesting hearing about ESA and all that's happening and all the future plans. So please join me in giving a warm thanks to Jan Woerner.
Thank you. That's okay. Good.
Thank you so much. That
Was fun.
I really would love to have you come back. That was really a fun dialogue.
Thank you very much.